हाँ, मैं आपको जस्ट थोड़ा इंट्रोड्यूस कर देता हूँ, उसके बाद आप प्रेजेंटेशन शुरू कर सकते हैं। तो इंग्लिश में करेंगे ना?
हाँ, इंग्लिश में करेंगे, समझ सकते हैं ना सब लोग इंग्लिश
हाँ
में?
बिल्कुल, हाँ इंग्लिश ही बेस्ट रहेगा, इंग्लिश ठीक है। Hare Krishna. So we welcome all of you to today's wonderful session, Science and Spirituality. And with us today we have Kali Charan Nayak, Dr. Kali Charan Nayak, who is a PhD in, he received his mechanical engineering from Indian IIT Bangalore. He's a gold medalist from NIT Rourkela, and he did his BTech in mechanical engineering from NIT Rourkela. He's been researching in past 17 years in aero engine, that is to do with the engines of the jet engines. And presently he's working in Rolls-Royce. It's a very renowned company as a specialist in air and thermal systems design. So Prabhuji is many years he's in the scientific field, and also he has been cultivating spirituality. So we'd like to hear from him today about what experiences or what insights he has got about science and spirituality. Thank you, Kali Charan Prabhuji, for being with us. Hare Krishna, please.
Thank you, Prabhuji, for the introduction. Good evening, everyone, if you are in India. So the topic today we are going to discuss is about jet engine. But although I will be talking some of the, in a layman term, about the design of jet engine, because as Prabhuji mentioned, I have been into this design of jet engine for almost last 20 years, and also trying to learn the parts of spirituality parallelly. Both may be similar order over 20 years. So I just wanted to give my perspective of how this design of jet engine, from this we can get a perspective of an intelligent designer when we look into this creation and get convinced that this marvelous creation must have a creator as well. And I would try to convince you this fact by taking this example of jet engine. So before we get into the topic of intelligent design, I wanted to talk about a concept called irreducible complexity in a design. So every design we have, it has several components. And here I have two examples. One is a mousetrap and another is a car. Probably it will be easier for you to look at the car. So when we say irreducible complexity, means we cannot reduce the complexity of the design further. If you reduce further, then the design is not going to work. So for example, in the car, we have 4 wheels. If you remove one of the wheel, it is no longer going to work as a car. Similarly, if you look at the mousetrap, there are about, it's a simple component. It has 5 parts: the platform, the spring, the retaining rod, all that. So if you remove any one of that components, for example, the spring, it is not going to work. So basic, very minimum, this requires these components. So that's what is called a irreducible complexity. So it cannot be further reduced to make sure that this component works or this design works. So every intelligent design, right? So every intelligent design will be having this component or this characteristic of irreducible complexity, And beyond that, what we are saying is this design is not coming by chance, or it is not something generated out of randomness, and it is not guided. So there is a factor called intelligence into it. When you call this is an intelligent design. So one part we discuss a design. The design to work, it must be irreducibly complex. Means it cannot be further simplified. And then there is another factor called intelligence into it. So for example, if you look at in that the top mountain where there are actually the pictures of a few presidents of America are there. So if somebody just looks at it, one cannot think that this the structure has come just by by rain or by deterioration in due course of time of thousands of years. So it is not. Somebody may think, okay, somebody had chiseled it, somebody might have done some nice way of cutting different tools and methods, but definitely one cannot think that this shapes of these the features of these presidents of America in a mountain has came just by erosion because of rain, all that. So there is a design part, intelligence part is there. Similarly, one cannot think that a gigantic house is designed just by that. So the point is, in an intelligent design, there is an intelligence, a guided intelligence is involved in the intelligence design. So these are the two important components of an intelligent design. Now we will look into a jet engine. So jet engine is definitely one of the marvelous creation of human mind so far we see in the current existence. And it is ultra complex. If you look at this cross section of a jet engine, it must be having more than 30,000-40,000 components. But definitely, you cannot remove one of these bolts or nuts in this engine parts. Then it is going to create an havoc, because this design has a purpose. We'll discuss what is the purpose of this jet engine. But each of the nuts and bolts and the various components in this engine has a role to play. So an intelligent design is the one which is irreducibly complex. And it is designed to perform certain function. It has a certain purpose in it. So an intelligent design must have a purpose. That is very, very important. It is not that we are designing these jet engines just out of our interest or something. Definitely not. So in the next 20 to 30 slides, you will see, just by looking at the process of design of a jet engine, how so much things are involved. So there must be, every intelligent design must have a purpose. Because to design, just to give you an idea, this jet engine, this operates almost like for 40 years. And about 1,000 of scientists or engineers work for a decade, almost 10 years, to develop an engine. So it is not like a child's play. So this must have a purpose in it. So what is the purpose? What is the purpose? So here we see in an aircraft, which is maybe Boeing 787. So there are engines. These are the two jet engines. So what is the purpose of the jet engine? If I ask somebody from a layman point of view, they can say what is the purpose of the jet engine. But here is the purpose told by the manufacturers. Because the designer knows what is the purpose. We may tell something, but the designer knows what is the purpose. So here is the purpose told by actually G Aviation. So there are three manufacturers. which manufactures jet engine. One is G Aviation, another is Rolls-Royce, and the third company is Pratt& Whitney. So this is the purpose mentioned by G Aviation. So I was working in that company for 13 years before I moved to Rolls-Royce. So this was what they were mentioning. The purpose of designing or these jet engines for GE is not to make profit. You see, they don't say that we have to make profit or we have to build this technology. No, that is not. The purpose is very simple. What is the purpose? The purpose is we have to invent the future of flight. Definitely a novel technology we have to develop, but the purpose is to lift people up. So they want to take people from one place to the other and lift people up and bring them home safely. So that is, just a minute, somebody's disturbing. So the purpose is very simple. You can see the purpose is just to take people, lift people one place, take one place to other, bring them home safely. That is very, very critical. We are dealing with life of people. So safety is pretty important, and transport them from one place to other. So if you tell this something to an engineer, if you ask, and they will take, oh, we want to reduce this efficiency, that efficiency, but that is not what the business wants. So the design of an aircraft engine has such a noble purpose in it. But now we look into how the design evolution happens from this purpose. So the purpose comes first. It is not the design comes first. It is the purpose comes first. So now if we have to lift people and transport them from one place to other, somebody can think of, okay, we have to design a piece of machine which will lift, and we have to have some people also inside that, so which will also have weight. And now we'll have to take them from one place to other, so the machine should generate certain amount of thrust. And when it is moving, obviously, because of the air, there will be drag. So these are the various principles, and the basic principles that are going to be required in a machine we are going to develop. That's why you can see this aircraft, which is having an airfoil shape. So the airfoil shape, the way when the air is flowing across this, that generates the lift. And this engine has to generate thrust to overcome this drag. And this lift will overcome the weight of the engine as well as the weight of the people we are going to lift. So that is the first principle, fundamental principle. So when we go and try to develop this engine, the first thing will come is the customers. Definitely, the jet engine, what we develop, it is not something what we use. We deliver it to our customers like Boeing and Airbus. So they will give the requirement, what they want. When we develop an engine, they will tell the requirement. So the first requirement will definitely be the thrust, because they have to transport people from one area to other. So they will say, we need this much of thrust. And definitely all the customers want to do business without spending anything, right? So they will say that, okay, develop an engine, I don't have to spend any fuel. But that is not possible. But they will say that, okay, the fuel consumption should be so less. And the government agencies, environmentalists, they have a restriction. So if you are the manufacturer, make sure that you don't pollute our environment. Okay, you do business, but make sure that you don't pollute the environment. So your smoke or carbon dioxide or NOx should be a certain level. At the same time, when you are having an airport, the general people will have a complaint. Okay, if you are having an airport nearby, make sure that you don't create so much of noise. So there will be a decibel restriction to it. Similarly, the other thing the customer will be interested is to make sure that the cost is minimal. At the same time, the amount of maintenance is less. They will also expect that, okay, at the beginning, we'll have to tell when we design an engine, how many cycles. They will say, okay, your engine should operate for 40 years first time I will go for sub visit after 5 years till then. So that is essentially the life of the component. So how many cycles? When we say cycles, it is like one takeoff and one landing. That is a cycle. And reliability plays a very, very important role in jet engine because we are lifting, we are dealing with life of people. So there should not be any in-flight shutdown, or in case the combustor fails to, when we go to certain height, sometimes there will be rain. So if the combustion somehow shuts down, it should be able to relight it immediately. So all these, there are several customer requirements, and this we must meet. It is not like we design these cars and the manufacturer will say, okay, this much of fuel consumption will come, this much of mileage will come. But if it doesn't come, it doesn't matter. We don't go and shout at the manufacturer. But in our case, it is not like that. If we are not delivering certain amount of fuel consumption or the pollution, definitely we have to give a huge penalty to the engine manufacturer or to the government agencies. So we have to meet our commitments, whatever we commit. But these are the requirements will come at the very beginning. So then how do we meet the requirements? So you see, so from the purpose, we have got certain principles. Now we have got certain requirements. So now we have to start our preliminary design. So preliminary design means we have to have an initial idea that to develop this much amount of thrust, okay, what type of engine we have to build. So the first is kind of a cycle. The thermodynamic cycle is a Brayton cycle. I don't know how many of you into, from technical background, but I'm trying to explain you in a layman terms how much you can understand. So we come with a thermodynamic cycle. So in this thermodynamic analysis, we will essentially try to build what would be the size of the engine. Means what will be the fan diameter, what will be the core size, such that the thrust that will develop will be based on how much of air we are taking in and taking out, how many stages inside the compressor and stages inside the turbine. So all this will be decided at the beginning based on the thrust requirement, and also they will tell what is the fuel consumption, because the fuel consumption or fuel efficiency is governed by the thermodynamic efficiency, which is essentially depending on the pressure ratio of the compressor. So the compressor pressure ratio that will drive the number of stages. So now you can see how those requirements now is defining the size of the engine. We should have how many stages, how much length, weight, all this will be slowly is coming out. So this is the preliminary design of the engine. But at the same time, when we trying to design this engine, all we want is whatever the total amount of flow we are taking, everything should be used for the generating thrust. But in reality, that is not the only requirement, right? When we are having an engine, there are so many other requirements. So for example, the passengers are sitting inside the cabin. So when you are in the flight, they need certain oxygen. So where from they will get the oxygen? So we have to supply from the engine. So that is what is called as customer bleed. So that much amount of flow we have to take out from the inside the engine and provide to the customer. Beyond that, there are several other things are there. Like in a thermodynamic cycle, the cycle efficiency will be maximum if we can operate the turbine at the highest temperature. So highest temperature, as much as high is the temperature, that much high will be the efficiency of the engine. So you can look at now the technology is so advanced that the temperature we can go high by putting more fuel into the combustor. But unfortunately, we don't have materials in the nature which can tolerate maybe such high temperatures like maybe 2000 degrees centigrade, like that. So we don't have such materials. So what do we do? There is an intelligent design which is coming. Essentially, what we do is, I will cover that part. How do we manage that? We will take some amount of cold air uh, and supply to the hot metal in the turbine to cool it. That's what is called blade cooling. So some amount will be used for blade cooling. So sometimes what happens, some high temperature air can also get inside into the domain. So we use it for some purging. So there are several other functions are there. I will not get into it, but the point is, it is not only the thrust we develop, but we have to make sure that the reliability of the engine, the other requirements like customer bleed. So there are, and these parts also have to run for like 40 years or 30 years. So there are certain temperature gradient, like the higher temperature at the disk and lower temperature at the bore. So that will give rise into huge stress. So what do we do is that's why we send some amount of cold flow, such that the rim temperature also reduces. So we manage the temperature gradient across the disk. So there are several other functions for which we use this secondary air. So this is called a secondary air because this does not contribute to thrust, but it is definitely required to get the life of the parts, to supply air for the customers, to operate the blades at a much higher temperature to improve the efficiency. So there are many other functions. So that's why the secondary air, you can see all this airflow is more or less looks like blood flow in the different parts of our body. So it's pretty complex. Then at the same time, you see that we need to make sure that the engine operates for the entire mission. So you can see during taxi, it goes, then immediately within 20-30 seconds, it just goes and takes off. So that is a period, there's a huge temperature gradient, and also the speed will change significantly when it is taxiing, and within 30 seconds or 20 seconds when it is taking off. So huge change in speed, temperature, all this, the extreme condition, it will be subjected. So we need to make sure that the engine is able to operate at such huge temperatures, pressures, environment, and these transients actually plays an important design challenge as well. Compared to like we have land-based engines, such harsh environments are not there. So here I just wanted to give you an idea about how these sophisticated blades are intelligently designed, right? Somebody may see this blade, say, what are these? Why they have these holes, all this? Why they have this curved shape? Why they have all this? Everything in this design has a purpose. And lot of analysis gets into it. I will also talk about it. You see, when you take a cut section of this blade, there are nice channels are there. There are again ribs are there, such that when the flow will pass through these different passages, and when these ribs are there, it will increase the heat transfer. So essentially, we send some cold flow, and when these ribs are there, the heat transfer will be much higher. So it can reduce the temperature of the metal, because outside we are passing hot air, and that hot air temperature is much higher than the metal can actually, the material capability. So that is the very wonderful thing. So how do we do that then? Then we send this cold air, so which will essentially not only maintain this metal temperature lower, but at the same time we have these holes. When this cold air is coming out of these holes, it forms a nice cold film. That is what is called film cooling. Nicely it will form a film cool, and then over that you have this hot air going much higher temperature. So you see, such a wonderful design where you can actually operate the engine at a much higher temperature, but at the same time you don't have a material, but you can form a thin film of cold sheet of air. But there is a challenge. If there is a high pressure ratio, all that, there are other design challenges are there. So we have to precisely meet that. So highly intelligently designed all these things. Let me move on. I should not talk too much, might be sounding technical, but I just wanted to give you an idea.
We are liking it.
Yeah. I'm just trying to give an idea by this, as that, how so much of effort, so much of thinking, so much of engineering and technology is into it. It is not coming. We cannot say that, okay, this blade is just like that. No, this hole is just like that. This has a purpose. This is another interesting physics of ingestion. People don't understand still. It is still, scientists, engineers still don't understand. So you see this combustion, it is where combustion means you are burning fire. It's like fire is there inside the engine. And this fire is passing through because that is the source of energy which is rotating this turbine. But what is happening is this entire gas path, this hot gas path is very hot. This is a high temperature. But the point is this is also low pressure. But what will happen sometimes, there are some stator and rotor gaps are there. There are some gaps. And in the flow, circumferentially, because there are blades also which is rotating, so somewhere you will have high pressure, somewhere you will have low pressure. So what will happen, sometimes this hot gas can enter into these cavities wherever the pressure is high and will go out wherever the pressure is low. But the problem is this hot gas can enter inside the cavity and go. But these discs are not designed for that, to get into this hot gas, because we don't have, if you use that, maybe material cost will be high, and sometimes we may not have that material. So we don't want this hot gas to come in. But it's a very complex thing. So what you do, essentially, we take some amount of, cold flow. It generally comes through this side, but this is coming from the compressor, so it will have high pressure. So high pressure but low temperature, and this is high temperature, low pressure. So what we will do, we will push this high pressure, low temperature, high pressure air through these gaps such that this hot gas cannot come. But it is not that simple. You see, there are some complex computational fluid dynamics analysis are done. Sometimes you see that this hot gas is actually coming inside. You see, this is the low temperature and this is some mixed temperature. But we need to thoroughly understand this. But what is happening in this region is not well understood. So generally what we do, we try to push more flow than required. So this is another important concept of ingestion, and how much of flow you should pass through these gaps plays an important role. This is really another interesting thing, very, very interesting thing, because you might be seeing on the front of the engine, right, this fan blade, and this rotates, in thousands of RPM, such a high speed, and then this cannot be exposed to the ambient air. Then it will have a huge drag, which is not possible. So we have a casing structure to cover it. When it is a casing structure, it is a stator, and this guy is rotating maybe thousands of RPM. So you must have to maintain certain gap. But when we maintain this gap, what happens in this gas path? Some amount of flow, when it is going from left to right, instead of getting compressed, it will bypass this. When it is bypassing, your efficiency is less. So whatever your customer is asked, you will not meet. Your component efficiency will less. Your SFC will be, fuel consumption will be more. So you are not getting whatever the compressor pressure ratio you wanted. So you have to minimize. One has to minimize this tip clearance. But how do you minimize? There are so many physics is there. When it is rotating, this will grow. This will go and hit. If you put a small gap, it will go and hit. And also we have seen that, when it is taxing all the way, it is going to take off within a 20-30 seconds. That is putting a tremendous challenge. And in one of the design, I have seen when during our design phase, we did analysis, but certainly there was some machine in the understanding the physics. So we saw this blade went and hit the stator, and there was a failure of this compression. And these gaps are so small. You can understand. I can't tell you the number, but it is the size of the hair. the size of the hair. So it has to be the design of the compressor, the thermal environment, modeling, all these things. Pretty much a good understanding what is happening in the reality, we have to do that. And for that, this is again, I'm trying to show, just trying to give you some idea how what is happening in these cavities. We have to understand the flow such that we understand what level of heat transfer is happening, because accordingly, the temperature of the metal will understand the temperature and the speed that will drive the growth, because both mechanical and thermal, because your temperature is more means it will grow more, and also your speed is more, it will grow more. So all this physics we have to understand. So both analytically, computationally, we have to do experiment. So many things we have to do really before sizing how much of flow to go, how much of gap, all that to design all this. And this complex level of analysis is required. So I try to give you some flavor, so much analysis gets, what I'm trying to say is so much analysis gets into the design. So that I try to give few examples, but here I'm just trying to summarize what are the various domains, because to design an aircraft or this jet engine, it requires several domains of understanding. A single engineer cannot do it. We need specialists in different domains, like to design the thermodynamics, we discussed the size. Somebody has to be in this in that specialism of gas dynamics. Then air system and heat transfer. These are the two of my areas of expertise, where we understand how much of flow, cooling flows we have to spend, how do we understand these hot gases are getting into the heat transfer. Then another is vibration. When the engine is there, it is rotating such high speed, there will be a lot of vibration. So it should not happen. Because of vibration, the shaft is failing. And stress analysis, because of the temperature and rotation, the components will be subjected to huge stresses, mechanical and thermal stresses. So the stress engineer will do that analysis, and also they have to, based on the stress, they need to declare by taking certain Asian core, like stress versus life, they should declare that, okay, this, because of this stress, your part can run for 10,000 cycles or 20,000 cycles. We have rotating shafts, so how to lubricate it, control system, right? So there are various control systems in the engine. So we need engineers with control system materials. Like you see, we don't have materials even presently to operate at the required temperature what we want. But that is always putting a pressure on the material scientist to come up with advanced materials to design what is the microstructure required. All that the materials engineers are always working on it. And that aerodynamics, what we discussed on the, we have aerodynamics and the external aerodynamics, but that is for the aircraft. But we have so much of internal aerodynamics, what is happening in the compressor turbine as the flow is passing in the gas path, combustion. As you can see, fuel now, fuel is a challenge. So far, the aviation fuel is slowly is repleting in the nature. So we have to come up with the combustors which can do combustion of alternate fuels like hydrogen, and in future, right? That's what is the path forward. They are doing the research on that area. There are situations where there can be some leak of fuel or oil. There can be fire, but we have to make sure even there is a fire, the engine is designed such that it can at least run the components. All different pieces are designed such that at least it will run for 5 minutes to a nearby airport. So don't worry about that's how it's designed. So much of other computational thing. Then with all this analysis, so much of analysis. This happens during the engine development phase, almost maybe 4 to 5 years, with thousands of engineers in different domain expertise. They will be working, and all that I explain is the analysis, technology, design part. But that is not only technology. There has to be some process. We cannot work very randomly. there is a project management, and there is a design process. As we discussed, the customer gives the customer requirement. Then the engine, like in our body, we have different system like a circulatory system, nervous system. Similarly, in the engine also, we divide into various systems and give that requirement from the product to the system requirement, then system to subsystem, then subsystem to component. Component means like a blade or a disc. And eventually these components are designed and then manufactured. After this is manufactured, the components should do component testing and see that the component requirements are met. For example, the blade efficiency is met and the blade stresses are met. Once that is done, all the components will be assembled in a, suppose, the different parts of a compressor. That what is called as a subsystem. So the compressor has to be tested and make sure that the compressor together, not as a single part. It has to do as a together, right? As a subsystem, like the compressor has to deliver the pressure ratio required. But not only the subsystem, the full system should be delivering, and eventually all the systems, when they are met together, it becomes the product. The product is manufactured, assembled, and eventually it gets tested, right? So this is what is called the engineering V. So that's how is the design process. It goes through design and verification, both the design and verification. So as I mentioned, all these things must be planned in a proper way. We cannot do things in random. There is a separate department called project management. There are different roles: project engineers, then senior project engineer, chief design engineer. So all these people are there, and they will be periodically, every week, they will be doing reviews, checking things. But eventually, what is the goal? The goal is the entire design must be completed in a given time. Say, for example, it is 7 to 8 years. Okay, it must be done. We cannot say that, okay, we committed to the manufacturer, will deliver the engine after 8 years, and you do it maybe 10 years or 13 years. That is not going to work. And when you are taking more time, also there will be cost associated to it. So cost, we have to meet whatever the engine development cost. And definitely quality is so much important for a jet engine where we are dealing with life. So all this must be meticulously planned. And we cannot just say, oh, I'm doing the design very nicely. Oh, I know I'm doing the best. No, we cannot say that I am doing the best. I am the best. We have to take to the senior chief design engineers or chief project engineers, like they will be reviewing, right? So there are constant reviews and audits of what the design we are doing. We will be challenged what analysis we have done, what results we have got. And these are the engineers who are reviewing. Not only they have studied, like done their master's, PhD, whatever, but they also, beyond that, they have worked almost another 30, 35 years. So our chief engineer is almost 35 years experience. So that person is almost having 70 years of experience in study and design, and definitely he contributed multiple engine designs. So from all this, you can understand how the complexity of the design process, analysis process, how it has to be properly planned, how it has to be reviewed. So much gets into the design of the engine, and then eventually it gets into manufacturing. Once it is manufactured and assembled, it will get inside a test bed where we'll put various instrumentations to measure whatever we wanted, right? Whatever the pressure, temperature at various locations in the engine, all that we'll have to measure and make sure that the design, what is intended, we are getting the required parameters based on the requirement given by the customer or based on our design. So there are several engine tests we will have to do, right? So I have just given a few examples. Almost This testing itself takes a couple of years, almost two to 3 years of rigorous testing is done, such that it will make sure that we are getting the required parameters. Also, it is meeting the hot and harsh environment. Say, for example, you might have heard in the flight that certain bird is getting ingested inside the engine, and there was a failure, or there was in-flight shutdown. So in reality, actually, we do some bird ingestion tests. There may be, when the flight is going from, say, India to all the way to America, there are various environments. At certain places, you may see that icing conditions are there, rain is there. So all this, when there is a anti-ice, there is another system called anti-ice is designed, but at the same time it is working or not, the operability is maintained or not. Similarly, okay, we have designed the engine in the ground condition. When we take into flight, whether the engine is delivering the required parameters or not. So there are so many engine tests done, almost, for thousands of cycles, almost maybe 15, 20 engines are I won't say spoiled, but that's what is done, right? So many, if the engine is good, definitely they will sell it. But several engines are also used to develop or test. So much so, all I was trying to explain to you is how in this jet engine, so much gets into it to design the engine. So can we say that this jet engine is just came by chance, or without any guided, or without any purpose? We cannot say. So from all these 20, 30 slides, whatever we discuss, the point I'm trying to mention is so much gets into an intelligent design like a jet engine. But even we do so much of effort, thousands of engineers, decades of time, so much of testing, so much of planning. Even after that, this type of catastrophic failures do happen. So here is one of the engine in CF6-80 of G engine in 2016. So one of the turbine disc just exploded. It is exploded so and so that it came out from one engine, it went and hit the other engine, and there was the other engine also got teared off. Almost there's an in-flight shutdown in South American Airlines. So catastrophic failure, you can imagine if we are one of the passengers in that flight, how we'll feel, our near and dear ones. This is another engine of Rolls-Royce, where there was one of the oil pipe which got actually, because of some vibration in the oil pipe got ruptured and the oil came out, and the oil only can sustain certain ignition temperature. The outside surrounding air temperature is much higher. As you can see that hot gases are there inside the turbine. Then there was a fire. So this is another havoc, isn't it? If we are in the engine, we are on the flight, and one of the engine catches fire, that's it. So these are the two situations where there were catastrophic failure of the engine. But there are other situations we know, like a few years back, Boeing 737 MAX, there was an issue with the control system of the aircraft. And we know not only one, there were two aircrafts which were carrying almost maybe each aircraft carrying some 250 people. Without there any fault, they just got into danger. Danger of life means what? They died. We also know maybe a few years back, there was a Indonesia, Malaysia Airlines. So the flight vanished somewhere in the ocean. Although we say the reliability of the engine when we design, we do so much of work. We say that it is 99.99999, but still these rare events. It doesn't matter. We may say in the mathematical term, the reliability is so much, but eventually there are several people who are losing life. So, however, the point is the human design will always have a fault. That's what we see. That's what is happening, although we are putting so much of intelligence into it. But now the question is, look at these wonderful birds. Either they are going single, they are taking nice dives, angles immediately, they are just landing, they are going together. So many flies, very small size flies are there. So can we imagine, or if we ask this question at this point, do you think these birds and these flies are designed or they have come by chance? So definitely after working 20 years in this jet engine, all this analysis, design, testing, I would not say that these birds have come by chance. Definitely they are intelligently designed. But not only intelligently designed, it is very interesting that these designs are also intelligent. Hopefully you got these two words. I have used intelligent twice. What I'm saying is these designs are intelligently designed. Not only that, this design itself are intelligent. Like these birds are intelligent. We humans are intelligent. So such kind of thing is not there in the creation of modern scientists or engineers or technologists. So definitely we should not very loosely tell that these creations or these designs in the creation have come by chance or by evolution like Darwin. So not only me, there are great scientists like Newton. When he looked at this orderly creation, he mentioned that this most beautiful system of the creation like sun, planet, and comet only proceed from the counsel and dominion of an intelligent and powerful being. So Newton is saying that this wonderful creation, how orderly it is working, the planets are rotating and moving, this must be coming from the counsel and dominion of an intelligent, vastly superior from the intelligence of this creation at least, right? So must have come from the intelligent and powerful being. That's what he says. So Einstein also says that everyone who is seriously involved in the pursuit of science must be convinced that a spirit is manifest in the laws of the universe. So Einstein is saying that one who is seriously in the pursuit of science, one who is seriously involved in the pursuit of science means he's trying to understand the truth. It doesn't matter whether it is science or spirituality. Both of them are trying to understand the truth of the nature. So if somebody is really pursuing science for that purpose and understands the laws of the universe and its creation, he will be definitely be convinced that there is a intelligent designer. That is what is the spirit is mentioned here. And that spirit or the intelligent designer must be vastly superior that of man, which is the creation. Definitely somebody who has designed something, the intelligence of that person must be vastly superior than that of the design at least, right? So that's what Einstein is telling, and he's calling that as God. So I think we have spent good amount of time, but still, can I take another 10-15 minutes?
Yeah, please.
Yeah.
You can take as long as you like. We have time. There is no limit you can take.
So we discussed about how from the example of a jet engine that the creation means the designs in this universe also must be intelligently designed. Not only we are thinking, there are great scientists like Newton, Einstein, and many others. I have not put it here. They are convinced. They are not convinced like us. Like Einstein, when Einstein and Newton are convinced, they are convinced maybe 1,000 times than us because they are really convinced. So how do they convince? They are, then we look into how there are certain intelligent designs are there in the life and the universe. So first we will take very simple examples in this creation. So in this universe, the fundamental particles, now people are trying to so far they have reached to a God particle. Maybe some other session we can do on God particle. But let us look at an atom, and in an atom we have electrons, protons, neutrons. But if you just look at the mass of the electron and mass of the proton, so mass, the electrons are revolving around the nucleus, and the neutron and proton are there inside the nucleus. The mass of the proton is almost 2,000 times than the mass of the electron. So why is that? Have we ever, we study in our syllabus all this particle physics or whatever, but do we ever question that why is the mass of the electron is so less compared to the mass of the proton? And what would happen, suppose if the mass of the proton or the mass of the electron is 2,000 times higher than the mass of the electron? What will happen? Definitely because of the high mass of the electron, then by the centrifugal force, it would have been, everything would have been like a fluid, no solid existence, right? We would not be existing as human beings, or the solid particles will not be there. So everything in the world will be lifeless, full of fluid, like pralaya, everything water. So definitely there is an intelligent design. Is that somebody who has designed the mass of the proton 183 or around 2,000 times. So definitely there must be an intelligent design. This is one of the Nobel laureate was told. So again, look at the charge of the electron and proton. Interestingly, the mass are so much different, but how are the charge of the electron and proton? One is positive and negative, but the value is exactly same. And here one of the Nobel laureate, there is one book by one of our teacher, our spiritual teacher, Dr. T.D. Singh. He has compiled 7 Nobel laureates. So there, one of the Nobel laureate is saying that if the charge of either electron or proton would have been a small difference, say for example 2 into 10 to the minus 18 times of the electron charge, then because of such a high, by such a small difference, and these electrons or protons are revolving at such high speed, whatever the force of due to the difference in charge would have been, that would have been so high that it would have overcome gravity. That means there will not be, everything must be flying. So no galaxies, no stars, no planet. And he is telling, it is not, I am telling, it is his words. He's telling no more physicist. He's just making jokes of the physicist, that you must understand, not only just to study the motion of electrons, protons, charge, what is the value, but you should understand why, and how. So this is electrons and protons, how they are intelligently designed, because these are the fundamental particles. They are kind of the building blocks of the universe. If the foundation is not strong, then the entire universe itself will not exist. Very, very fundamental and very nice things. And if we look at this creation, the various matters are composed of these 4 fundamental elements. Carbon, hydrogen, nitrogen, oxygen. 99% of it is made out of this. and this lightest elements have strong. So the amazing thing is how these four fundamental elements, and particularly this carbon, hydrogen, all these are leading to, many of the biochemists or maybe from biologists, they think that, okay, from how life has evolved, they are saying, okay, from this you can manufacture protein molecules, all this, and eventually life can evolve after so many billion years. But definitely that is not the case. So life cannot be manufactured from these biomolecules. That's a topic for another session. This is very interesting, very amazing. Water. Without water, we cannot survive. Without water, we cannot survive. And we know how nicely this H2O, this bond angle, 108.5 degrees there. So precisely this angle is there. It is amazing. And all the solid particle, all the solid substance, if you put on a liquid, suppose if you put an iron in a liquid iron, it will actually get inside. But if we put ice over water, it does float. Is it not amazing? Every other solid just sinks inside the liquid, but in case of ice, it is floating. Oh, you may say that, oh, I know, no, you do not know, sir. Actually, the density of ice is less. Yes, I also know. But who made? Why? Why is the density of ice is less? That is the question. The question is why the density, why is the structure of ice is made like that? Do you have an answer? Definitely, this must be designed. Suppose if we think ice also must be sinking in water, what will happen? What will happen? So in the ocean, we have so much of living elements are there, living creatures are there. Suppose at one time, because of surrounding temperature, ice is formed on the surface of the ocean. What it would happen? Then all that ice will be sinking inside, right? So when it is sinking inside and the ice temperature is so low, and it forms a covering for the living elements, then there will not be any life inside the ocean. So such an amazing thing the creator has designed. There are many. I have just taken few examples. So here are two compounds maybe. One is hemoglobin, another is chlorophyll. You look at the structure of the hemoglobin. Hemoglobin, all of us, we need in our blood, it is there, this iron, which actually transports oxygen. And without that, nothing will work. Our brain will not work. Nothing happens, right? So hemoglobin is such a very fundamental particle, fundamental, compound, we can say. But look at the center in the structure, iron is at the center. And almost similar thing in the chlorophyll, there is a magnesium. And magnesium is what it is doing. It is actually this chlorophyll. The magnesium is responsible to convert sunlight and carbon dioxide into, it actually captures the sunlight. If magnesium is not there, then definitely there will not be any food formation for the plants. And similarly, if inside the hemoglobin this iron is not there, definitely our circulation system will not be working as it is working now. So from all this, we should understand that how such nicely this iron and magnesium is placed. So somebody might have definitely selected and placed at the required position. So amazing chlorophyll and hemoglobin. So those are some of the examples, in the creation, of some of the fundamental things in the creation, how we see that they are intelligently designed. So then I just wanted to also show some examples how in life also, not only in the creation, in the life also, how it is intelligently designed, even in that inside a single cell. So one of the microbiologists are, in the creation, some of the fundamental things in the creation, how we see that they are intelligently designed. So then I just wanted to also show some examples, how in life also, not only in the creation, in the life also, how it is intelligently designed, even in that inside a single cell. So one of the microbiologists are, in the creation, some of the fundamental things in the creation, how we see that they are intelligently designed. Why it is getting repeated?
Sorry. From my side, it's okay. I can hear properly. Maybe now is better.
Yeah, now it is.
Okay. Yeah. Sorry, maybe I opened some software, that's why.
Okay. Yeah. I just wanted to play Michael Behe, actually, who is one of the pioneer of intelligent design. Okay. Can you hear now the audio?
We are not able to hear the audio. Maybe there's some setting, you have to check that setting also.
Okay, now probably you will hear.
Okay.
Motor on a boat. It rotates to propel bacteria through liquid, and it's necessary for their survival in order to swim to search for food.
Yes, I can.
Flagellum has a number of parts: a drive shaft,
We are not able
a
to hear the
universal
audio.
joint, a rotor.
Maybe there's some setting, you have to check that setting also.
Oh, you are not able to hear. Okay, now probably you will hear.
Okay.
Motor.
I can hear, Prabhuji. There was some delay problem, that's why. My voice was 1 minute later, you heard. So it's working, it's okay. You can play it as previously you were playing.
Parts: a drive shaft,
We are not able
a
to hear the
universal
audio.
joint, a rotor.
Maybe there's some setting, you have to check that setting also.
Oh, you are not able to hear.
Bushings,
Okay, now
stator,
probably you will hear.
even a clutch and braking system. The motor of the flagellum has been clocked
hear
at
probably. There was some
100,000
delay problem,
revolutions
that's why.
per minute.
My voice
And
was
as with the
1 minute
mousetrap,
later, you heard.
removing even one
it's
component
working,
of
it's
this
okay.
elegant machine
You can play it
destroys
as
its
previously you were
functions
playing.
and renders the bacterium, shall we say, dead in the water.
Maybe there's some setting, you have to check that setting.
The flagellum
you are not able
is
to hear. Okay, now probably
irreducibly
you will hear.
complex, even a clutch and braking system. Now we know that the motor of the flagellum has been clocked at 100,000 revolutions per minute. And as with the mousetrap,
Keep in mind,
removing
the
even
flagellum
one
is
component of this elegant machine destroys its functions and renders the bacterium, shall we say, dead in the water.
Maybe there's some setting, you have to check that setting.
The flagellum
You are not able
is
to hear.
Yeah, there is some problem. It is repeating the
There's some
sound
problem,
again.
yes.
Maybe you can, I can share the link. Please send me the link and I will share it on the channel. Then they can view that video later on. You can share the link later on also. You can continue. You can just summarize what he was telling.
Okay. Yeah, now it is okay now.
Yeah, now it's better.
Okay. So I'll just share the link later. You can see the presentation now, or I will have to share, I think.
Presentation is not showing yet.
Okay. Yeah.
Yeah, now it's showing.
Okay. Yeah. So what Professor Vehe, he was telling about this single cell microbe bacterial flagellum. This is also very nicely, wonderfully designed. So here this filament is there, which is actually rotating, and there is a inversional joint here. Here is a stator, here is a rotor, and this protein molecules. So all this, how nicely it is this filament is actually rotating, and then for the direction change, there is an inversional joint. And because of this rotation, actually this bacterium is actually able to propel, it is able to move. So this also looks like, a small propeller design, even in a single cell microbe. So that's what Professor Behe was telling. So this, so what we see is inside the creation and also life, various things are intelligently designed. So it is not only intelligently designed, it is also fine-tuned. So what is fine-tuned? Precisely, maker further and further, it is further, like we go from an ambassador to all the way, maybe in the recent advanced engines where the SFC is less, sound is less, so many new features. So there are further refinements. Fine-tuned means further refined. So look at in physics, there are almost several constants. The speed of light is this much. There is a gravitational constant is this much. Planck's constant is this much. There are so many constants. What does it mean? That somebody has fine-tuned, precisely designed this. So here is a physicist, Nobel laureate, Professor Charles Townes. So he says that these are unique physical constant of our universe. If the value of these physical constants have been slightly different, like we discussed, the charge of the electrons and protons, then the universe would have been very, very different, very, very different, very, very different. So that means somebody has precisely designed, right? Sometimes we think that our Earth is a special place for living, right? And he tells this statement that every structure, like this creation, how it is nicely designed and it is fine-tuned, this structure must have also a purpose, such an intelligently designed. So the structure must have a purpose. So he's coming on the other way. Like we saw that how the aircraft, we started from a purpose, then the design came. But an intelligent person like Charles Townes, who is saying that such wonderful structure must have a purpose. So the structure and purpose must be related. This is something, a food for thought. We have to think about it. So what he's saying is every design must have a purpose. Whatever we see, and we look at this wonderful creation, so the creation must have a purpose. The creation must have a purpose. It is not there something by chance. And we, as part of the design, like human beings or different species, that must have a purpose. Must have a purpose. This is another Nobel laureate, Roger Penrose. Of the couple of years back or 1 year back, he has got. He's a great mathematician and a physicist. He is also involved in also a cosmologist. He says that the universe has a purpose and it is not there somehow by chance. So this point we can further, maybe in a future session about cosmology, we can discuss. He has derived a probability at the beginning of the universe. So how, it is so small that this must have a purpose, he's telling that. So this is a very important thing, that our existence and the existence of the creation, this is definitely has a purpose. But what is the, so the question now comes is, who is such a wonderful creation is there? Who is the designer of this creation? And we are also telling this wonderful universe of this creation is there. There must be a designer. So who is the designer? And we constantly saying that the intelligent design must have a purpose. Then what is this purpose of this creation? So that actually, the answer to this question, we cannot get it from the modern science. Because what is the purpose of this universe? All this gets into the domain of philosophy, or particularly in our case, Vedanta, gives a very, very clear description about how this creation is coming into place. Vedic cosmology is there in Srimad Bhagavatam, 5th canto. It gives a detailed description about the creation. Not only creation of this physical gross elements, but also subtle elements like mind, intelligence, ego, all that are how this creation is happening. And it is also stating the purpose of the creation. So we'll get into now the other part of the topic we discussed, how from this intelligent design, we can get into the existence of God, right? So we must understand first, what is God? Because different people have different understanding about God, different definition of the God. But there is a clear description or definition, what does God mean? So as per Vedanta, here is a reference in Srimad Bhagavatam. It says that Sthiti Udbha Pralaya Hetur Ahetur Asya. It means that the God is the cause of Sthiti Udbhava Pralaya. Udbhava means creation. Udbhava, from where it is coming. He is the source. He is the source of this creation, or he is the cause of this creation. Sthiti, maintenance, when it is existing, right? Even to sustain thing. So he is the cause, and pralaya, eventually this universe. So even cosmologists do not know that what will happen, what is the fate of the universe. But clearly, based on our Vedic description, the universe at some point in future is going to dissolve. And he is the hetu, he is the cause. That means God, the creator, the designer, the intelligent designer of this universe is the cause. He is the hetu. But ahat ahetu asya, but there is no other cause for him. If there is no other cause, then that will be called as God, right? So definitely, he is the ultimate cause. He is the ultimate cause. So that is the fundamental definition of God. Even Vedanta Sutra says, Janma Dasya Jataha. The first aphorism of Vedanta Sutra is Janma Dasya Jataha. Janmadi means the same thing. And the cause and sustenance and maintenance, sustenance and dissolution, everything is the cause. That is the one of the definition of God. So that means he is the creator. So every creation, based on Vedanta, the creation, as we can understand, must have an intelligent designer, and Vedanta is telling that God is the cause. That intelligent designer is called as God, and he is the cause of this creation. In Bhagavad Gita, very nicely, even there are several places this definition is there. Even in Bhagavad Gita in 10.8, Lord says, Lord Krishna says that aham in 10.8, Lord says that aham
sarvasya prabhu.
Aham sarvasya prabhu matta sarvam pravartate iti mattva bhajante mam buddha bhava samannata. Aham sarvasya prabhu. So I am the cause. I am the source of both this material and also the spiritual creation. So even in Vedan, in Brahma Samhita, Lord Brahma also says, Ishvara Parama Krishna Shachidananda Vigraha Anadir Adir Govinda Sarva Karana. He says that Lord Govinda, Krishna, he is the cause of all causes. And in Bhagavad Gita, Lord says, I am the cause of all causes. And in Bhagavatam, it is said, whoever is the cause of all causes, that is called as God. Lord, in Bhagavad Gita, 15th chapter, he gives so much definition, so many details about how he is the cause and how he has intelligently designed all this. This is a sloka in 15.13. He says, Gam avishya cha bhutani dharayami aham ujasha. So we are seeing this nice, beautiful creation. As Newton said, there must be a creator. It must be coming from the counsel and dominion of intelligent being. And here in Bhagavad Gita, Lord says, I enter into each planet and by my energy they stay in orbit. So what is keeping them to stay in the orbit? It is because of my energy. So Lord is the cause how these planets are in the orbit, right? So we see ISRO is sending so many satellites and they survive only for certain years. After that, ISRO has to send another or several other satellites. But you see how these planets are there as designed, because there is a certain period of the universe that is definitely much higher than how our ISRO satellites are running for certain years. So if so much of energy has to be sent in the ISRO satellite, how do you think these natural satellites are there just like that? And here the Lord is saying, it is because of my energy. Here another verse in 15:1-2, Lord gives an example about the sun. So sun is such a powerful, at every second it is generating, you see, 4 into 10 to 26 words. So much of power within a second, which can be, thousands of mega power plants, almost 5,000, 6,000 mega power plants. I don't know in India how many power plants we have, maybe in tens. So it's almost like this entire earth right now, whatever, so many power plants we have, how much power we are generating, we can run actually, these power plants can run for several years by 1 second of the energy generated by the sun. Such a power, such amount of power. And for the very survival, definitely we need sunlight. And you can see there are so many layers from the sun to all the way to earth. We have troposphere, stratosphere, ionosphere, so many layers are there, and each of the layers are doing different function. And we get a small fraction of energy on the earth, and such harmful rays like ultraviolet rays, how they are getting, scanned through when the sunlight is passing through. Those harmful lights are actually, filtered before reaching the Earth's surface. Although now by pollution, all those layers are getting destroyed, and there is scope of that sunlight is coming to us and creating cancerous effects. But in the very creation, the Lord, how wonderfully the sun is there and different atmosphere layers are there. And here in Bhagavad Gita, the Lord is saying that the splendor of the sun, you see all the energy that you see in the sun and moon, and that is coming from me. Another place, we see for our survival, definitely we need sunlight, right? If we don't have sunlight, we cannot survive. Another thing is the moonlight. Why the moon is there? And here Lord is saying, moon is the cause of supplying juice. Juice means whatever we see, these vegetables. In all these vegetables, pusnami chaushadi sarvam samo bhutva rasatmakaha. Rasa, all the juice, whatever we see in the fruits and vegetables, all this is coming from moon. All it is coming from moon. Definitely we may not have an idea, but there is a PhD scholar who is telling that because of the lunar cycles, the gravitational pull is created in the land, and during full light, full moon, and new moon time, more moisture is stored in the soil. And yeah, maybe I don't know about the other details, but definitely if we believe this person, and also we have faith on the Lord statement. Definitely, we don't know how this juice is coming, but clearly, Lord is saying it is because of moon, right? This mineral and vitamins or the juice, whatever is there in the fruits and vegetable, it is there. So can we imagine our life without having these fruits and vegetables? So all our minerals, mineral and vitamins are coming, whatever we are eating. Essentially, all our immunity system is built by these fruits and vegetables, and the source is the moonlight, and that is coming from the Lord. Another place in this chapter, 15th chapter, Lord is saying that Aham Vaishnavan Bhutva Praninam Deha Ashritaha Pranapam Samayuktaha Pachami Annam Chaturvidham. So Lord is saying that there is a digestive fire. What is the? I am the source of that digestive fire. So we can see how the Lord has designed this digestive system, and we are able to survive, but there is also a digestive fire. And that digestive fire is able to digest the different 4 kind of foodstuff, eating, chewing, licking, drinking, all that different type of food, what we are taking. Everything is digested in this digestive tract, but there is a digestive fire. This is Jagnatni Agni, there is a Agni in GIT, which is actually is responsible for the digestion of the foodstuff. So even if we eat so much of food, but if the food is not getting digested and assimilated, so what will happen our fate? So here we can see such wonderful digestive system, and the digestive fire is designed in this intelligent design of the human being. So similarly, we see there are several wonderful systems are there. Like we saw in the aircraft engine, there are various systems. Here also in this human being, our body, almost all the mammals we see, this so many systems are there, like digestive system is there, immunity system is there, nervous system is there, circulatory system is there. So many systems are there, reproductive system is there. So I'm really amazed by looking at this heart, because I look at it as a mechanical engineer. So this heart acts like a pump, but we see pump or like a compressor. But in our aircraft engine, we have a compressor and we also have a turbine, because the compressor requires energy to rotate or to compress. But how this heart is pumping? Where from? What is the machine which is giving energy to the heart? Can anybody say? No idea. Similarly, we have this nervous system. So in recent times, we are working on this artificial intelligence, and we are trying to mimic how the neurons are working, how there are different layers in the human nervous system. There is just a very elementary stage to understand how these human neurons are working. But even with that basic understanding, we can have only in our artificial intelligence only a few layers of neural network. But in human, there are so many layers of network and how they're complexly connected. But we know from artificial intelligence that only if you just keep increasing this number of layers, the computation cost is so high. But how efficiently in our human intelligence this nervous system is working with so much less computation power. So definitely somebody must have designed this nervous system like that. And all this very coordinately, how they are nicely working, like somebody pinches at one place, all of a sudden within no time there is a very good coordination, nice coordination among all these various systems. So definitely it is worth somebody who is a doctor or maybe a biologist, they will appreciate much more than me. I just try to look at the mechanical aspect of this, but definitely even from that single example of heart or the nervous system, it shows amazing how the body, our body system is designed. So similarly, the eye.
One interesting fact I'd like to share. You'll be surprised to know, also all the viewers, when I was studying in my 12th class, 11th, 12th class, I had biology. So there, the teacher told us that when the body is formed, the very first organ, do you know the very first organ that is formed in the embryo?
Heart, huh?
Yeah, it's the heart. And the heart is, it has a sub-brain. That means before the brain is formed, before the brain gives a signal to the heart to pump, the heart has an inbuilt brain, very basic, which gives the direction to pump, that you have to pump blood. So before the brain is formed, the heart is the first organ. So the surprising point is that at that time I was reading Bhagavad Gita. So in the Bhagavad Gita, Lord Krishna is saying, Sarvasya chaham hridi sannivishto, that I am situated within the heart. Ishvara sarva bhutanam hriddeshu, that Lord is situated within the heart. And also we, the soul, the jiva, atma, we are also situated in the heart. So when I heard that in my biology class, it was amazing. I was convinced that, Bhagavad Gita already is saying that we are in the heart. And this is the first organ that is formed in the embryo. And it is, like you were amazed how the pumping mechanism. So I was amazed at how it has its own system of, activating and pumping without the help of the brain. So this points out to the Atma or the Paramatma who is situated within the heart and who is doing this transaction. So the more, the more we understand, the more we research, the more we try to find out, the more we will get to real understanding or the true understanding. And then we can appreciate the spirituality, we can appreciate our scriptures, that how satik, how precise they are. And another wonderful example is the embryology given in the Srimad Bhagavatam, which is as good as modern embryology. Each month the developments are told. And so these are the things which increase our faith. Sometimes people, they think, why so many educated people, they're joining spirituality? So the reason is because spirituality has substance. It has, it's not just some fake or some idea. It has substance. It's true. Okay, Prabhu, please continue.
Yeah, thank you, Prabhuji. Similarly, I also happened to be in ICU for one of my close relative when actually he expired. It is the heart actually, which was still working till the end, because his other parts, become dysfunctional, but the heart was still, kind of pumping. So heart, as you mentioned, heart is the component which is working or created at the beginning, and that actually works till the end.
It is mentioned as the seat of the soul. The soul is sitting in the heart. Like somebody asked me this question, and the answer is, they asked me that where is the soul in the body? Where does the soul sit? So in the Shastra, it is given, it is sitting within the heart. And by your personal, your experience, you saw that the heart was the last organ to be functioning. And when the soul left the body, then the heart stopped.
Exactly, yes.
So this is very, the more we do research, the more we are coming to the truth.
So certainly this point clearly says, the heart is getting that pumping energy from the super soul, and similarly, and it is operating till the end because the soul and super soul are still there till the end. So that really, if you have noticed or understand all this, you get fully convinced that existence of soul and super soul. So this is another example of eye. I was teaching my son about this eye in his science book. So one thing I saw is how the Creator, the Lord, has made this eye is flexible. Suppose you, if there is more light is coming, you all of a sudden go to a bright sun, or you come to a dark room. The membrane stretches, and such that its focal length changes. So I was really amazed that can the modern scientist can develop a glass which is very flexible and its focal length can change. Definitely, at
Actually,
least it is not there.
that's what modern science does. They take ideas from nature or from God, and then they copy it. That's how the camera was made. They studied the eye and they made a camera. So modern science is copying that from the original creator.
That's why there is a full domain of biomimicry is there. So they are trying to copy many things. Many things, even in aerodynamics, they are trying to copy from the creation bird and all. So yeah, exactly. So we discuss many things, maybe in the physical creation, but there are subtle things where from this intelligence is coming, where from this forgetfulness is coming. Who has the answer? Because it is not that, just because the scientists do not know, but we have practically seen, we have experience. And we also discuss in the intelligent design, one of the very important part is intelligence, right? So where from the intelligence comes? So Prabhuji has already mentioned, so it is the same sloka where Lord is telling, Matta Smriti Apahanam Jnanam Cha. From me comes intelligence, forgetfulness, and even memory. And I am seated in everyone's heart. So as we discussed, the heart is the first component which is designed at the very beginning and finished at the end. That is really wonderful. I didn't know that heart is formed first, but I knew it was at the end. So when you asked, I was guessing that.
That is why I shared, because it's really amazing. When I heard it in my class, biology class, I was I was very interested that this is what the scripture is saying, and this is what modern science is also saying. Because the heart is pumping, and all the proteins or all the molecules needed for forming the tissues, it is transported by liquid, that is the blood. So the heart has to transport all of this tissues, I mean all the material. And the soul is seated within the heart. And then around the heart, all of this body is formed. That is the sitting place of the soul. So I mean, real scientists, they will they will go towards knowledge.
Exactly. So both of these things are consistent, but the point is, the scientist can understand the physical thing or maybe slightly maybe metaphysical thing, but for the subtler thing and spiritual things, they cannot understand where from the intelligence is coming, where the memory is coming. They cannot understand.
Modern science also,
there is
they don't
limit.
have an idea about mind, intelligence. They don't know clearly how to define it.
So there is a limit. So that is the place, starting point of spirituality. So since it is a science mostly based topic, so the conclusion of today's session essentially looking at the jet engine, looking at into the creation, the fundamental particles, how they are designed, looking at some of the live particles like even the single cell microbe, or looking into the various structure in our own body in human beings. We can conclude that if so many thousands of engineers, scientists, and also they have to have a chief engineer to design a jet engine, how can such a wonderful creation which is orderly working, which is more sophisticated, as we have observed, must be intelligently designed? So it also should have a supremely intelligent designer. And when we design things, it has a purpose. This creation also must have a purpose. And that intelligent designer, in spiritual circle or in religious circle, it is called as God. Although different people can call with different name. And definitely, we cannot find out the purpose by looking into the textbooks of science from physics, chemistry, biology, what is the purpose? Because the purpose is known to the designer, who is God, and comes in the platform as we discuss in spirituality. So definitely, I'm sure Prabhuji must be covering all this in the spiritual topics. So that is the beginning where science ends, spirituality starts. But at least what we know, our Vedic scripture says the purpose is Ashoto ma sadgamayo, tamosha ma jyotirgamayo, mrityur ma mritargamayo, om santi santi santi. So this creation, by studying this creation, we should understand and try to be more inquisitive. Athato Brahma Jigyasa. That's why it is said we must be curious to understand. We must inquire. We should be more inquisitive to understand. Oh, such a wonderful creation is there. Our body is intelligently designed, so there must be God. And what is the purpose? And what is my connection with the God? Connection with this creation, connection with others, and what should be the purpose in my life? So at least it is said, Asutoma Sadgamayo. So now we are in a temporary changing thing. So we should endeavor for to go from Asat to Sat, and from ignorance to knowledge, and from Mrityu to Amrito. So that's what our scripture is pointing us. Definitely, these are the topics might be covered or will be covered in the classes of Bhagavad Gita, Bhagavatam. So with this, I will stop here, Prabhuji. Thank you very much for all of you. Although it took a little bit more time, I hope this will be useful. Thank you. Hare Krishna.
So we thank you so much, Kalicharan Prabhuji, for sparing out your valuable time, although you are well qualified and very busy, but you are still, from your heart, you like spirituality, and you are taking out time and energy to share your knowledge with all serious, inquisitive people. So one or two points I would like to add, which I found interesting during your presentation. I remembered something that some great scientists, they admit, like you took the example of Newton. So he admits that the more I find out, the more I understand about physics or about science, the more I realize that how much I don't know, how much still is yet to be known. So this is the sign, or this is the we can see that those who are actually intelligent, they become humble. In the Bhagavad Gita also, Lord Krishna says, Vidya Vinaya Sampanne. One who is wise, he is humble. So the scientists who actually understand their limitations or understand the complexity and vastness of this creation, they become humble, and they acknowledge that there is some superior force. There is some superior being who is running this show, who is doing this wonderful activity. So there is a notion that science means atheism, but in actuality, there is another very nice quote. I don't remember the exact scientist, but he said that an actual scientist will be forced to believe in God. The more he researches, the more he sees that there is a purpose, there is a design, and it's a particular number. It's not just randomly some number selected. And also there's a very wonderful example given by Srila Prabhupada. Srila Prabhupada was once walking on the beach, as he does his morning and evening walks. So there was an airplane coming from the ocean towards the runway, towards the airport. So Srila Prabhupada gave an example. He said that, so the modern scientists, they seeing this situation, they'll say, once upon a time, suddenly the ocean gave birth to an airplane. So modern science is studying this phenomena from the middle point. It is not going farther back, that how can an airplane simply come out of the ocean? where did the airplane come from, and try to research more. So modern science is just like Darwin is saying that, suddenly there was life, suddenly. So nothing happens suddenly. Everything is, has a cause. Everything has a cause. So this is I remember this analogy Prabhupada gave. He said that, suddenly from the ocean, an airplane took birth and it came. So evolution sounds like that. Suddenly some chemicals mix and suddenly there was life. So yeah, it's not like that. So yeah, although today our time is over, we could have much more discussions, but we'll leave that for our next session. Maybe we'll invite you again many times. You have many wonderful topics to share with us, and we like to learn. Also, everyone else on the channel, they were interested. They have opted for science and spirituality seminars, although maybe not so many maybe joining right now because they're busy or whatever reason, but this will be staying on the channel and people will be viewing it. So again, I thank you so much for taking out your valuable time, and hopefully we'll again have another session.
Thank you,
Okay,
Prabhuji,
thank you.
for the opportunity.
Yes, thank you so much, Prabhu. Hare Krishna.
Hare Krishna. We'll close it here, Prabhuji.
Yeah, you can just